Anyways, so the momentum equation is just mv, so that v is additional in the rather the mass flow equation. When we are applying the Lorentz rule, we can find the volume integral about control volume and the surface integral about the control surface. So rho v dot n. So n is the unit vector perpendicular to the surface. So this is equal to F net. So this F net is our mass times acceleration. Finally, after solving this equation, what we can get is mv out minus mv in is equals to F net. So this is a general form, but in a specific Cartesian form for x, y, and z component, mvx, or we can represent it as u, v, and w, which is equals to m dot vx out minus m dot vx in is equal to F net in the x direction, in the y, and in the z direction. So this is the kind of momentum equation. So you can apply this momentum equation for, as example, you can take this flow. You have a streamline flow here. Okay, so point 1 is here, point 2 is here, and the flow field variables U1, V1. U1 is velocity in the